Let's see how to build PMOS diode connected PMOS common source amplifier. So here both the resistor and the our main transistor both are the PMOS. So first of all I need to create the circuit, and so this is the new circuit, and I need to go to these components and I need to get the PMOS. So here is the PMOS. We are using the monolithic MOSFETs. So yeah, this is one PMOS. Okay, we need the two sources, that is VGS and VDS. So okay, I'm just giving the voltage. This is our input and this is our VDS. Okay, so this is the VGS. So in the PMOS, remember there will be the P channel. So here we need to provide the negative voltage for the input. I need to click the wire and I need to just connect this one. So this has to be the negative supply. So let's make this input as a sine wave, and let's say its offset voltage will be minus 0.8. Okay, let's take this as a minus 0.8. So this has to be greater than minus 0.6. That's our cutoff for the threshold voltage for this PMOS. And let's say amplitude we have is a 1M and the frequency of 2 kilohertz. So this is what our input for this PMOS, and we need to connect this to the ground. Now we're done with our input part for this PMOS. Now we need a resistor. So always remember, in the PMOS this is source and this is gate and this is the drain. It is opposite of the NMOS. So in NMOS it is like drain gate source, but here this is the source gate and the drain. And always this base is connected to the source side. So we just need to connect from here to this side. Okay, so we connected it, and we need a resistor. So okay, let's say this is a resistor. Let's move this a little bit side. Okay, this is our sine wave, and we need to connect from here to here, and okay, and from here to this one. I need to connect this from here to this side, and from here to here, and here this is a VGS. So and it is VDS. So here VGS means this is the gate and this is the source side which is connected here. That means we need to even ground for this one. So this is just a simple PMOS common source amplifier. For more information regarding this, you can watch the previous video of constructing this PMOS common source amplifier. Now we need to replace this resistor R with the PMOS diode connected. So okay, now let this be 1.8 volt. So this negative side, that means the negative voltage we are providing here. So the current will be flows from source to the drain like this. So okay, let this resistor be 2k. Now if you want to run and we just see what may be the output now. So for running this I need to do the transient analysis. Let's say 10 millisecond, and this has to be 0 and this has to be 10. Now if we see the output, then okay, the gain is very less. So we just need to set these 1 micro, and even this is a 100 micro. And even we forgot to mention what is the cutoff for this PMOS. That means we need to create a model. So for that, just go to this spice directive and type dot model. Okay, so it has to be dot model and the PMOS, and here I need to mention the KP and the VTO values. So KP equals to 200 micro and even the VTO equals to minus 0.6 for the PMOS. So we will keep this here. So now if we run this and okay, so this is a little bit from 1 volt to some 992 millivolt. That means we are getting around 8 millivolt of the gain. We can even increase this. So okay, we will just try by changing this from 0.8 to okay 0.7, and we will just check it. Okay, we will just change to 0.85, and now yeah, here we can see this has a almost gain of 10. So from 540 to 550, the gain is very less, only 10 we have. So we can just change with these parameters and you may get a little bit higher gain. Okay, now our main intention is to replace this resistor with the PMOS diode connected. So for that I'm removing this resistor, and instead of this resistor we need to have a PMOS diode connected. So this same PMOS we need to copy again. Okay, we will copy this PMOS and we need to place this here. Always remember the diode connected means this gate and the drain, these two has to be shorted. So this is our drain and this is our gate. We need to short these two terminals. Then it becomes the diode connected PMOS. Okay, these two we shorted. And from here we need to give to this negative supply. That means to complete the circuit. Now let's maintain these source, that means this base and this base both are at the same potential. So let's maintain like that. So instead of connecting here, we just continue to connect this to the base of the another transistor or the PMOS transistor. So now let's run this and let's see what will the output. So now the output is minus 150 to 149. This is like only the 1 millivolt, that means only one we have, only one, the gain is only one. So the same thing happened in when we took the NMOS amplifier with the PMOS or the NMOS diode connected. So here the gain is not higher, so we need to construct some other circuits to get the good gain. But here the main thing is that without this register, that means without the register, we are using this PMOS to in order to work as a register. So because we cannot get the actual register, that's why, that means constant value for the register, that's why we are making use of this PMOS diode connected to act like a register. So if the resistance value of this will increase, then we may get the good gain. But in these kinds of circuits, it is very difficult to get the gain, higher gains. So we need to switch for the further advanced circuits. I think you understood this. These two values, okay, this 1 and 100U, and this is okay 1 and 100U. We can just change and we can see even instead of 100, okay, let's make this as a 10 and let's check it. So now also the gain is almost 6 to 9. That means okay, now it got a gain of 3. That means it's a very less gain. I think you understood about how this is used as a diode connected. Thank you.